Hi, very good afternoon to all. Myself, I am Shani. Today we are going to discuss about illumination basic and lighting schemes. So what all the topics we are going to cover here is introduction, electric lighting, terms used in illumination, lighting schemes, design of indoor light scheme, factors required for light scheme, and finally illumination levels and so on. So coming to introduction, as we all know that the primary source of light is sun. The sun is the natural source we are getting day to day. And we are also experiencing many artificial lighting schemes as well. In our day to day life, we are using lights in many ways. Yeah, it's correct, right? The electric lighting are mainly used for household-based decorative purpose as well as advertising, traffic control, medical fields. These are only not we are using in many ways. So for everyday livelihoodness, light is the essential source for every living and non-living things. Is it correct, right? Yeah, obviously it's correct. So primarily natural source is sun, and artificially we are experiencing two kinds of lights, that is mechanical lamps as well as electrical lamps. Mechanical lamps are poor in their performance and hence that has been completely vanished, and electrical lights and electrical lamps only been using nowadays. So we'll discuss about electric lighting. So electric lighting. What are the advantages of electric lighting? Why we are using this? The electric lighting has cleanliness. It is pollution free and we are getting cleanliness, and it's very easy to control as well. So remote based or switch based, however we can control it easily, right? And it's economical, easy to handle as well. If it's get any repair or anything, we can easily make it, right? Okay. Next, better reliability. Better reliability is nothing but better performance. We're getting what the input we have expected, what the input we have given, the output will be the same. So reliability, the performance of the lights, whatever like LED or LCD, whatever the light performance will be very good and suitable for almost all purposes. Electric lights is nothing but it is not particularly for certain place or certain thing or certain, okay. It will be useful for almost all the purposes we need the electric lightnings. Next, what are the terms used in illumination? Next concept is terms used in illumination. And the first one is light, luminous flux, luminous intensity, illumination. Everything that is light, luminous flux, luminous intensity, illumination, these all the things covers about the lighting schemes itself. Okay, so individually we are going to discuss this. What is a light? Light is a form of electromagnetic energy. There's a pot of radiant energy from a hot body, which produces a visual sensation on human eye is called light. The whatever the thing we are going to see, that is called light. Visualization. That is, we can see, we can observe, we can sense it. Light. Is it right? So that is called light. So light can be of different colors. Is it right? We have vibgayors. Vibgayor is nothing but different colors of light we experience. Why we are experiencing different colors of light? Because of varying in the wavelengths. Wavelength also depends on the radiations. Yeah, we can consider white light, red light, green light. However, example, if we go for hospital emergency, they will be indicating as red. If it is success, operation is success, then they will be identifying it as green. So based on the wavelengths, the colors may be varying differently, and light is not only of a certain color, we have multiple colors based on the wavelength. Next one is luminous flux. Luminous flux is nothing but to measure the light, we need to find the flux. First we need to measure the flux. Then only we can measure the light. Flux is nothing but rate of flow. Rate of flow of radiant energy. Radiant energy is radiations. How much radiations, how much radiant of energy per second is consumed for the sensing of luminous body is called as luminous flux. And also we can define it as rate of flow of radiant energy. First definition is total quantity of radiant energy per second responsible for visible sensation from luminous body is called luminous flux. Or also we can define it as rate of flow of radiant energy. And the main units for measuring luminous flux is lumens. You can say the units for luminous flux is lumens. Next one is luminous intensity. So everything will be linked individually, like light. Light to next luminous flux. Light, as we discussed earlier. So to measure the light, we are going to consider luminous flux. Okay. Next line, luminous intensity. For the directions, we have multiple directions, right? So the light will be emitting. The emission of luminous flux in that direction, in certain direction, is called luminous intensity. Basically, luminous intensity is denoted by I and its units is candela or candle per C. So, the definition is luminous intensity of emission of luminous flux in the direction is the luminous intensity. Or else we can say it as luminous intensity of source in a particular direction where luminous flux to the solid angle. So luminous flux is denoted by F. Solid angle is denoted by omega. So I equals to F by omega. This is the luminous intensity. Next one is illumination. When light falls on surface, it becomes visible to the visible. The phenomenon is called illumination. So light will be falling on the surface, right? We can see that. We can feel that. So whatever the light we can see that falling on the surface, that phenomena is nothing but illumination. So it is defined as, so illumination can be defined as luminous flux falling on surface per unit area. Okay, per unit area. As we have, if we consider one building, we have square feet areas, right? So per unit area, how much light is falling? Okay, that is defined as luminous flux falling on the surface per unit area. It is denoted basically by E. Okay, and its measure is lumen per square meter. Area will be measured in meters or centimeters, whereas flux is measured with lumens. Hence E equals to F by A, that is lumen per square meter or meter per angle. Okay. Next is lighting schemes. So lighting scheme is not how the lighting has been designed based on the requirements, based on the essentials. We are going to design lighting in different schemes. So basically we have 5 different lighting schemes. Okay, first one is direct lighting, second one is indirect and semi-direct, semi-indirect, general diffuse lighting. So the words itself we can understand direct, indirect. Direct means direct approach, indirect means indirect approach, semi-direct just 50% and semi-indirect just 50% and general. General is nothing but overall. Okay, in that we'll go with this. First one is direct lighting. So the name itself says that direct lighting is nothing but complete light falls on the surface or any object, that is called direct lighting. So here it is stating that as it is clear from the name, in this system almost 90 to 100% light falls directly on the object. 90 to 100, so complete light falls on the surface. Then it is called direct lighting. So the light is made, how the light falls on the surface? Because of deep reflectors used in that. Okay. Next, such type of lighting scheme is mostly used in industries and commercial lighting. Where we are going to use this direct lighting is in industries and commercial slots. We are using this direct lighting. And we are facing much problems with direct lighting. The problems like glare and shadow. Glare is nothing but heavy brightness and shadow. So if light falls completely on the surface, if we walk on the floor, okay, our shadow will reflect. And this is one drawback, glare. And as we have discussed, 90 to 100% falling on the surface means complete light is falling. That means heavy brightness will be there. That brightness may affect our eyes as well, and we can impact many things. If some people will be experiencing skin allergies as well because of heavy lighting. So these are drawbacks in direct lighting. Next concept is indirect lighting. Indirect lighting, word itself says it won't reach the surface directly. It completely indirect. So the title itself says indirect lighting. Hence we can describe it as 90% of light falls upwards, means away from the surface. Only 10% we can consider it falls on the ground. So here we can say that it is glare free, right? So brightness will be falling upwards, but we can experience little bit downwards. So no problems for eyes. So it is harmless. We can say that it provides shadowless, and also completely you are not experiencing light, right? So it is shadowless. That also we cannot notice and experience. Mainly this will be used in decorative purposes, like in cinema halls or hotels or some other way we can use this indirect lighting schemes, and we can see the indirect lighting schemes as well. Next one is semi-direct lighting. Semi means half. Half will be upwards and half will be downwards. Same way. This is an efficient system of lighting, and chances of glare are also reduced, because completely if it 100% falls only, we are experiencing 100% brightness. If it is 50-50, then why will we be experiencing glare? We can think that it's reduced, right? So 60% of the light is directed downwards. In this way, semi-direct, 60% will be directed downwards and 40% will be upwards. So this is provides a uniform distribution of light and is best suitable for rooms with high ceilings. We can place these kinds of lights where high ceilings, like building construction, they will be deciding that ceiling should be very high. In that time we can use it semi-direct light. Next one, semi-indirect. Semi-indirect is, this is also same way, but that is directly falling on the surface, but it indirectly falls. It covers the ceiling of the percent, like a 60%, and 40% will be on the surface. So semi-direct 60% downwards, 40% upwards. In semi-indirect, 60% upwards and 40% will be downwards. If a very small amount of light is observed by the ball is nothing but on the surface. Okay, it's mainly used for interior decorations. So some will be using plaster of Paris works, right, on the top of the ceiling. So they will be placing these kind of lights on the sides for decorative purpose. It shows like some hall, cinema halls kind of things, right? That we can say the example, best example. Next one is general diffuse lighting. General, the word general itself says general. It covers every part equally. Okay, if we consider 40% falling on the surface, 60% will be a ceiling. If not, 60% downwards, 40% will be upwards. It's general. Whatever the requirement is there, we can construct based on that. Okay, general is nothing but it will cover overall, like ceiling as well as on the surface. That is nothing but general diffuse. So lightning schemes covers, first one is direct, second one is indirect, third one semi-direct, fourth one semi-indirect, and finally general diffuse. These five things covers the lightning scheme. Next one is design of indoor light schemes. So interior works, indoor, outdoor. Indoor, what are the requirements? How we can design the indoor based on the lighting schemes. Okay, So to design the indoor, we have to keep these points in mind so that the look, the appearance will be very good. Okay. So first point, it should provide adequate illumination. Illumination is nothing but what we can see visually, right? So we should have visualization very clear. Next one, it should provide uniformly distributed light all over working plane. So wherever we are working, every spot should be same lighting. If we consider one room is there, it will be dim, another room will be dark. So why? Because designing interior work is not good and the placements of lights is not done very good. So we have to place the lights uniformly so that the light will pass uniformly on overall working plane. Okay. Next, it should avoid glare and shadows as far as possible. So mainly we have to avoid glare, that is over brightness. Over brightness may damage our eyes, and we also should avoid shadows as far as possible. And it should provide light of suitable colors. So whatever in some homes they are planning nowadays, during night they are choosing one color, during daytime they are choosing one color. So based on the requirements, the suitable colors to be placed. These the things we have to keep in mind to design the indoor light schemes, that is illumination, uniformly distributed light, should avoid glare and shadow, and also should provide suitable colors based on the requirements. Next, factors required for light schemes. What are the factors mainly required to design the lighting schemes? You have to keep it in mind before designing. So first one is illumination level. Next one, quality of light. Next one, coefficient of utilization, depreciation factor, space height ratio. Illumination levels. What are the levels we have to maintain to design? For example, like different places, offices, we can consider 100 to 400 lumens per meter square. Illumination level should, it is not the exact one, we can maintain in this range. Next, coming to schools, we can consider 250 to 400. Industry, 1000 to lumens. Shops, 250 to 500. Hotels, 80 to 100. Hospitals, 250 to 3500. This is the just on scenario planned. Based on the requirements, we can vary the values as well. Okay, this is the thing. Next one is quality of light. So quality should be maintained. Is it right? Quality is nothing but it should not be harmful. It should not affect any way to the human. Okay, so we are the viewers. So we should not face any harmful because of this light. So based on that thing we have to design. So quality is must. So clarity is what can we consider like clarity? It should be glare free. Glare free is nothing. Heavy brightness should be controlled. And also shadowless. Every time if we feel like shadow is falling beside us, backside us, front doors, then we feel something irritating, right? So it should be shadowless and contrast free hard. And long shadows can be avoided by using a large number of lamps. So if we use large number of lamps, then we can avoid the shadows as well. And we should adjust the heights. Height should be, if height is very less, we can experience huge radiations. If the height is so far, we can experience less radiation. So height is also mandatory. So we should maintain this quality of things to protect ourselves. Next one, coefficient of utilization. Coefficient of utilization is nothing but lumens reaching at working place to the total lumens emitted by the source. So how much lumens reaching the working place, that is surface, to the lumens emitted by the source. For example, if the light is emitting certain radiations, if it falls on the surface the same radiation, if it considers sun, nearer to the sun, the radiations will be very high. But coming to the surface, that is earth, the radiations will not be same. Is it correct? So, Lumens reaching at working days by total lumens. Total lumens will not be reaching. So that ratio we are considering as utilization factor. Usually the values vary between 0.5 to 0.8. Next one is depreciation factor. The total flux emitted by the source and fitting may be reduced due to deposition of dust upon the surface. So we are placing certain lights on the ceiling. If we clean that, the brightness will remain the same. If we left it for months together, the brightness will be reducing because the dust will be covering the lights. So that it will reach the surface very less. Okay, so what can we say depreciation factor is? Similarly, quantity of light reflected from the ceiling and walls also decreases with the passage of time. This is called depreciation factor. That's if time goes on. If we did not clean the lights or bulbs, then dust will be forming on that. So light will be reflected will be very less. Hence we should clean it and we should keep it as we require. That factor is nothing but depreciation factor, and usually it varies from 1.3 to 1.6. Last but not least, space height ratio. Space height ratio. If we consider one plot 20 cross 40, so that is length width. Okay, so 20 40. So how we have to design? The spacing will be very high. Ceiling should be very low or very less. So we have to design the light, to place the light, to feel the light. We have to think of space height ratio as well. Okay, spacing. How much spacing? How much light we require? And at what point we have to place the lamp so that it will reach the working plane completely and we can experience safe light. Okay, so these are the points we have to keep in mind before designing the lights. Mainly these are points: space, height. Spacing we have to think, as well as height we have to think. Based on that, we have to place the light and we should experience the equal level of light which should be safe to the human. So mainly these points you have to keep before designing the lighting.